Hello, everybody. This is Tammy Katz with the Requirements Working Group. I want to welcome you all to our meeting for April. We have a guest speaker today, and he's going to have a presentation and then a bit of a discussion opportunity. And these are one of the requirements topics that I think are real interesting because it gets down to what's good enough. How can you determine the quality of your requirement set? So some guidance on this is really appreciated. Henrik, you've put some thought into this. Would you kindly introduce yourself and go ahead and proceed on your topic?
Yes, thanks, Tammy. And I really appreciate the opportunity here to talk to this fine group about one of my favorite topics, requirements. My name is Henrik Mattfolk. I'm a principal systems engineer at Whirlpool and the technical lead for implementing SE processes in our development process. We're also responsible for educating and coaching the organization on systems engineering. I've been in this capacity for about 6 years now. Today, I want to bring a requirements engineering problem to your attention that we have been fighting, and I would say that we are still fighting. And I'm sure that we are not the only ones that are fighting this. It's the ever-growing requirement count and the complexity it is bringing to the set of requirements. I will start here with framing the problem and present a concept that will at least help mitigate some of this growth. If not managed, this ever-increasing complexity will risk to depleting some of the value of having requirements, because it becomes really difficult to interpret and manage a complex set of requirements. I also like to say that I'm coming at this problem more from a practical perspective and maybe less from an academic perspective. So what I'm going to present to you today is based on the experience we have gained over the years working structure with requirements engineering. And I also want us to have a dialogue about it. I will not target to take the whole hour, so I will save some time for discussion here at the end. I'm definitely seeking input from the professional community that we have here today. So with that, are there trade-offs to be done between characteristics of requirements versus characteristics of set of requirements? A little bit from a value perspective, or in order to kind of help with mitigating this complexity of the requirement sets that can risk to really erode some of the value with the requirements. Just to kind of frame the problem statement here. So we often see that requirement sets end up containing a really high number of requirements. And this high number of requirements really have a negative impact on the comprehensibility of the set. Can be a little bit difficult to understand the big picture, what is really important. It also takes a lot of time to manage these requirements and at the end verify the systems to them. So a requirement set that is difficult to comprehend loses some of its value. And let's look at some of the kind of dynamics that we have in place here. If we start to reason here a little bit on the value that we are generating with having requirements and requirement sets, if we can increase the value, we will definitely increase adoption as well. It will be easier basically to adopt kind of a good practice around requirements engineering in the organization. And if we can increase adoption, we will get more value. And the assertion here is that if we look at the characteristic of the set's kind of comprehensibility, if we can increase that, we will also increase the value generated. And what I specifically like to talk about today is a little bit this connection between comprehensibility of the set of requirements and how that kind of interact with the singularity characteristic of individual requirements. This may not be the only feedback loops that exist, but we're going to look at two at least. And this is maybe not a PhD thing that created this, but it's more kind of logical reasoning. So here's the logic. If we increase singularity of individual requirements, it means that we're going to also increase the number of requirement expressions in total in the set. If we increase the number of requirements, we're saying also that we're going to reduce the comprehensibility of the set. Okay. So just looking at that feedback loop, it feels like, yeah, but let's do one requirement then, and then we find we have a really comprehensible set. But that's not the only feedback loop that is in place. So we have this other one here. So if we reduce singularity of each individual requirement, we risk to increase ambiguity of the requirement statement itself. And if we increase ambiguity, we're going to hurt comprehensibility of the set itself. So we have kind of two feedback mechanisms here. So that is kind of suggesting that maybe there is a little bit of trade-off or some kind of optimization here in order to reach kind of maximum comprehensibility. And you can kind of illustrate that as you see in this picture here. So we have singularity here and comprehensibility here. If we go really, really singular, we're going to generate a lot of requirements. And the risk is also that we kind of divide things that naturally goes together. They get kind of scattered. You get a high requirement count. That's going to impact the comprehensibility of sets. If we go to the other extreme, let's say that we have too low singularity and we bring a lot of stuff into each requirement statement, that's going to cause them to be ambiguous, and that will also hurt your comprehensibility. Of course, you need to know where you are on this spectrum, but I think it's very common that you probably are somewhere here. You have a huge requirement count and you're trying to reduce it. So what we're going to assume here is going to be beneficial for us to move at least a little bit in this direction, maybe move a little bit up here on this curve to some kind of optimum here. So if we look at the different characteristics for individual requirements here on the left and the characteristics of a set, you see this kind of relationship here between singularity and comprehensible. If we start with trying to optimize each individual requirement to its characteristics, the question here is, will we necessarily end up with an optimized set? And this is a kind of important heuristic in systems thinking that, oh, maybe you shouldn't optimize parts in isolation, because if you do so, you may not necessarily optimize the system and the system as the set. So it's probably good to look at this a little bit from both directions here. So for the sake of this kind of conversation, let's look at, I'm going to call it a job. You can see it as a use case as well. What is the job that someone is doing with the requirement set? And there can be several jobs here, but let's focus on this job of interpreting the requirement set. There's a lot of different roles who need to do that. What is an important metric that a person is using trying to do this job? A metric that kind of is important for the outcome to be a positive kind of experience, something like that. And what we're focusing on here is really to minimize the time it takes to interpret this requirement set. So if we can come up with ways that at least reduces the time it takes to consume the information, that seems like it's generating more value. So that is kind of the value proposition here. Can we reduce this time? So let me use an example here to illustrate the idea or the concept here. So let's look at a function here to bake cinnamon rolls allocated to an oven. But we're not going to talk about the functional requirement here, but we're going to focus on an example related to functional performance. Maybe some performance aspects when we perform this function here is a little bit how well these are coming out of the oven. And there's a couple of different things we can look at here. So we bake the cinnamon rolls, then we will evaluate the result. For example, we can look at top browning evenness, bottom browning level, bottom browning evenness and level, and what the edges look like. So let's say 5 different things. And then we have our template for industry standard, who, what, how well, under what conditions. So if we write up a requirement here related to one of these performance aspects, let's say top browning evenness, it can look something like this. So the performance aspect is top browning evenness, and then we have a target for how well that need to be done, and we have an under what condition statement here as well. Okay, but that was one. We have 4 additional performance aspects here. If you continue and write up those as well as separate requirements, now we start to get quite a lot of information here. Basically 5 different requirements talking about these different performance aspects. What is worth to note here is also that this is kind of I refer to it as a treatment, or you kind of bake the cinnamon rolls. So you do kind of one treatment of the thing that you're actually evaluating here. So it's not different treatments. How can we go about to try to simplify this and get it a little bit more kind of understandable? So let me talk a little bit about the idea here, or the suggestion. So if we look at how we construct a requirement statement with who, what, how well, under what conditions, what we want to do here is to reduce the singularity, to reduce the number of requirement expression. That's kind of the idea. And how would we do that? So the suggestion is to relax a little bit the singularity characteristic on the how well part, but not on the what part. That should still remain singular, and it should communicate this one thought and not have multiple thoughts in there. Looking at trying to combine these 5 requirements into one statement by accepting that, yeah, we can actually have several success criteria or how well kind of conditions for how well these cinnamon rolls are coming out. So what would that look like? So if we would open up the scope a little bit on the what part, we could do that. For example, if you see here, we have top browning evenness, top browning level, bottom browning evenness, but all of these things are on browning performance topics. So that's kind of the thought. We want to make a statement about browning performance. We're not being as kind of descriptive on the what part, but we're still managing it responsibly, if you want, to not open it up too much. But now we need to state all these things that we will actually look at after the test is done, but we need to get that into the how well statement. And that can be worded something like better than target criteria or something like that. We use this as just a reference to an attribute. Worth to note here is that under what conditions is still the same, and who is also still the same. And if we look at the test case associated with this, that would also remain unchanged. You're kind of baking these oven, evaluate all those different performance aspects after you're done, but as part of the test case. Just to show what that would look like in total, that would enable us to reduce that down from 5 requirements into 1 requirement. And the what part is browning performance, but then we're listing through an attribute the different performance aspects that we're going to look at in order to deem the system compliant or passing this requirement. So you're overbuilding the how well here with 5 different things. So if we just zoom out a little bit, think about again the value proposition here we had with minimizing the time it takes to understand what the requirement set is communicating. If you were to read this instead of that. And just some numbers here. So this would generate actually 3 times more words to read compared to this one. But we're not losing any information here. We're still communicating the same thing, but we're saying it with fewer words. I don't know if you heard this expression, but thank you for the information you did not give me. We have a lot of information we're processing every day. So if we can reduce that a little bit, that would be great. Let's look at what that can look like in a requirement management tool. You integrate those 5 requirements. It would look like this. You also have test cases associated with each requirement here. You can actually, in this case, you can see by the number that it's the same test case. But that is also something that maybe can be a little bit, okay, should I run these tests individually, or can I run it once and then I can evaluate these things? At least you may have to think a little bit about that when you read it, so you interpret it correctly, compared to if you have this. So now you're overbuilding the how well part with all these criteria that you're going to look at, and you have the same test case, but it's going to be mentioned once in this case. So it's a little bit easier to interpret this, and much fewer words, one test case. It's going to be one test we run here, and then we're going to look at those things. So if we have some benefits there in maybe the time it takes to interpret that set of information, there are downsides for sure. One thing would be the impact on the granularity of traceability. We have a vast amount of requirements at the system level, for example. Maybe from your stakeholder level, you will have a healthy fan out, but maybe if you fan out a lot here already, maybe you won't get much fan out when you're decomposed to the system element level. Maybe that's not good either. But if you start to consolidate a lot of requirements, you can get into this situation. Okay, I have a lot of stakeholder expectations, but not so many system requirements. And then you get the fan in here, and you kind of lose a little bit precision in your traceability. Maybe you lose up here, but you gain down there. But that is definitely one risk here, that would we lose so much precision in the traceability that would be a problem? Or maybe, let's say that you have a requirement set of 1,000 requirements. Do you actually need that level of traceability, or would it be fine with maybe cutting that in half? That's from case to case, but I think at least for us, I feel that maybe we have a little bit more granularity in the traceability than what we actually need. So let's look at another example here. So the previous example was a performance requirement related to functional performance. Maybe this is a little bit more of a constraint, but this could be a functional performance as well. Whenever you have a list of things that need to be present, or a little bit how well is defined by a list of things, in this case, maybe you need a function in your system to visualize product data. We need to have these information items present. So that becomes a requirement. So what you can do then is to write an individual requirement for each, saying this function need to produce that information item on its output. And that would generate 4 requirements. But we can also consolidate that into using the same principle as we just looked at, to open up the what part. And instead of putting which information item, instead we're just saying that it should contain target information items. Then we list those information items on the target attribute. Now you're communicating exactly the same thing, but you do it through one requirement, and you're overbuilding how well with a couple of things that need to be present. Of course, if any of these 4 things would be missing on the produced label, for example, then you would fail this requirement, and you won't know what is actually missing unless you go into the actual test case and read through what actually failed. It's going to look like you're failing the entire requirement, while if you have this approach and you have an individual test case connected to each, then you can see that, okay, I failed this one, but I passed these 3, for example. But that also requires that you have individual test cases. So that is another consolidation opportunity there. So whenever you have lists under what condition is the same, and you can produce fairly kind of bounded what. Okay, let's look at another example here. So this is related to regulatory standard. A lot of information, sometimes really complex success criteria. This is about electrical system robustness. This is made up, but let's say that the regulatory standard would mention a couple of things that need to be true in order for the regulator to deem that the electrical system is robust enough. So it can be related to, okay, the harness needs to be dressed in a certain way. Maybe connectors need to have some kind of material class. And also this thing we see a lot in regulatory standards. There might be alternatives. No, but you can also look at, if you don't like to do that, you can do this instead. Okay, so either of those is okay. Maybe some ground connection, robustness, and power cords to be protected and so on. You can, of course, produce these as individual requirements. It gets a little bit tricky also when we have these core things to deal with that when we have individual requirements. But this is another opportunity. And I think here the potential is actually quite significant in order to reduce a requirement count. Because what you can do is come up with a good what part that is fairly bounded. And then you just say that you're going to comply to a couple of criteria here, and then you call the criteria out inside this attribute. You'll basically list these things. It's a little bit easier, I think, to deal with these kind of or conditions. We deal with a lot of those. Can be, for example, if the product has a glass control panel, then you need to do this. But if it has metal panel, then we're going to look at it this way. So those kind of things can be a little bit easier to deal with when it's kind of structured. So those regulatory things, especially when it comes to construction, we see there's a lot of success criteria that can generate a vast amount of requirements. And we see typically that regulatory can be maybe 60% of your requirements, which is quite a lot. Can be even more, actually. And of course, when you do this, you need to make sure that you have one test case that verifies that. And all these things would be verified through just an inspection test case. Another example here related to durability. That is also something that often generates many requirements. Usually there is some kind of treatment you're taking the product through. Let's say in this case, we could have a durability expectation. If I brew 1,000 pots of coffee with this product, so after I'm done with that, I have an expectation that there's a number of things that kind of need to be true. That can be, for example, some miscoloring expectations. Maybe the coffee still need to maintain a certain temperature. Plastic parts need to have survived that, and so on. Again, you can use this technique instead of stating them as separate requirements. They're actually the same kind of, you perform the treatment of the product, you take it through that 1,000 pot of brewing, then you're going to look at these things. It could be that you actually need to decompose this to maybe other constraints or functional performance requirements. But if you do it this way, then you have one requirement that kind of communicates that. Those were the examples I wanted to go through. Just to wrap it up here. So we have tried this a couple of times on different requirement sets, and this is a typical reduction that we see. In this case, we got around 40 to 50% reduction of the total count of requirements in the set. A couple of hours of work to look at those consolidation kind of opportunities, and that had a really nice impact on the readability of the set. So a little bit more visually show what that looks like. So if you're able to reduce the requirement count from 100 to 50, for example, it would look something like this. So instead of having this thing to read through, now you're going to have this thing. The same amount of information is there, but you're going to do it through more artifacts. So we're not kind of losing information here, but we're losing a little bit kind of granularity in your traceability that we do. You're going to go from a granularity of 100 here to a granularity of 50. And that may or may not be a problem. What are other kind of techniques here in order to help you with comprehensibility? So we could talk about this for a long time, but just some kind of general thing. Always in requirement sets, you want to choose your heading structure wisely. That is unfortunately kind of a static view, so it's kind of the structure of the set and it doesn't really change. We have definitely seen an advantage in organizing into sections for functions, and under each function you have function performance, you have a section for constraints, and then for interfaces. But there's many ways of organizing your set in order for it to be readable. But again, the heading structure is just offering a one static kind of view of that. What I think is much more important here is that you plan up front the different views you like to be able to create into the set. And those should be defined based on different usage scenarios, what different people like to see, and try to reduce the views down to what they need to be able to look at. We would like to be able to create those different views of the mountain, so we don't need to look at the whole mountain all at once. That can be pretty complex. And the famous heuristic of 7 plus minus 2, that's maybe difficult to get to, but you want to probably have some level of granularity in how you can define the views into your set. And once those are defined and you're aware about which ones that make sense, you need to plan attributes accordingly so that you can query those views. So you have something to query for. So you need a couple of attributes probably to support that. But you also have trace links and traceability to help you to create those views. Typically, tools are pretty good at using attributes on the requirements to create different views into the set. If you, for example, like to query for a function, maybe you can just query on the name, but maybe have an attribute as well that defines the function. To be able to use trace links, and especially the objects that trace links are pointing to, that's a little bit more challenging for the tools. But I think that has a really, really nice potential. So for example, show me just the performance requirements related to a specific function. If you have trace links from those performance requirements over to the function object in your architecture model, that is a very nice relationship to use and to be able to query in order to create those views into your set. But we see there's not a lot of tools that can do that, not at least when you work in the tool. Maybe you can create a report in a separate kind of reporting engine, but maybe not when you work in the tool. I think that was pretty much what I wanted to say. So what we looked at here was a way to basically overbuild your requirements, making them a little bit less singular, but have a potential to really reduce the number of requirements. You're not losing information. Maybe you're losing a little bit of traceability, but that can make your set more comprehensible, or it will be faster to interpret it. With that, I'm really interested in feedback and just have a conversation about this.
Henrik, can you see the chat? You just have a couple of questions in there.
All right, so one is, how do you trace the importance of one stakeholder's input against other stakeholder inputs also? So the importance of one stakeholder inputs. So assuming that several stakeholder needs would link to the same technical requirements, yeah, it's going to be difficult to understand who has the more stringent expectation unless it's obvious from the way the stakeholder requirement is written. But typically, one situation you can face is, for example, let's say some kind of EMC robustness or something like that. Okay, regulatory, they may have one expectation, but the consumer, actually from a quality perspective, they will maybe not be very happy if the product perform only to regulatory. And maybe you have just one requirement that communicates that. So how would you know exactly what each stakeholder need and how important that is? That would, in that case, have to be, I guess, through attributes on the stakeholder requirement, or just divide the system requirements so that you have one technical requirement tracing to each individual stakeholder, and then it's a little bit easier to manage. So, I mean, there can be those situations where it's not practical to consolidate this too much because you confound stuff. So maybe that is a situation where you would risk to confound and you need to basically back off. Where do compliance input get mapped into the... I'm not sure if I understand that part, but if you want to speak up and clarify that.
So the question of compliance comes into play when we're examining typically the safety and security risk. But when we look at bringing these things in to, like, say, the fan in, so to speak, there's the customers, there's different stakeholders, and then you've got folks from compliance. Typically, the compliance are constraints, but not always. And how do you homogenize those? How do you map those in and reconcile them amongst different compliance agencies, foremost, and then go against the stakeholders, presumably the corporate and customer stakeholders, and then come up with a rationalized set of fan in, and then ensure that you don't lose the fidelity of the compliance, because that's always a big no-no, because you get into the gray areas and it's like, well, we thought that meant this. And that's part of the challenge, of course, when you start looking at ways to synergistically combine things, you may lose some of that fidelity.
Excellent question. So the way we deal with regulatory standards is that in the stakeholder space, we kind of break them down into usually, at least the more complex regulatory standards, they are kind of nicely organized in clauses. So let's say a complex standard maybe contains 50 clauses or maybe 100 clauses. So that's basically the granularity you have in the stakeholder space, then that's what we do at least. And we don't necessarily need more traceability than that. But each clause may generate, let's say, 5 requirements. So then you get that kind of fan out there from the problem domain into the solution domain. And sometimes those, let's say, 5 requirements within a clause of a regulatory standard, they are maybe on the same note. Maybe it's like the regulatory example I showed, a construction, electrical system robustness construction clause. So there is maybe 5 things that need to be true. Do you need to break them out into 5 different requirements to see that they, basically maybe more for test kind of granularity? Well, those 5 technical requirements would trace to the same regulatory clause. But if you consolidated them, if they were on the same topic and had the same verification method, you could combine it into one requirement. And maybe you don't need more traceability than that. And it's still going to trace up to that same stakeholder expectation. I don't see a scenario where you can consolidate things that cut across different clauses in a regulatory standard. I don't think we ever seen such an example. So there's definitely a limit to this. You can't take it too far because then you start to confound too much. But maybe the short answer there is, do you actually need that granularity, or is it okay to reduce it a little bit and not get that many artifacts?
Yeah, for compliance type things, especially when you get into like digital assets, that level of granularity is a non-starter. You have to be able to do that. You have to be able to trace it back, and you have to be able to prove that you can deliver privacy and trust and all those things. Yeah.
So in that case, then you shouldn't do it. But there could be other scenarios where it's okay to, I can check all those things. And from a regulatory perspective, I only care about that those 5 things are fine and they are verified. And I don't need more granularity than that. Again, from case to case. When you utilize this new property, are you always using the target criteria property, or do you only populate it when it's needed? So we always use this target criteria property, even if you just have like one success criteria, let's say one number, we still use the same attribute. So we just construct it that way. In that way, you don't need to change the statement either. If you would add, or maybe have a more complex statement, adding a range or something like that. So we always use that approach. Is there a way to enforce a consistent vocabulary to enterprise catalog, perhaps? Very good question. You want consistency across your set, right? And consistency with architecture models and stuff like that. So I'm open to suggestions. We have thought about creating like widgets that can help us to write. And I think I've seen integration stuff between requirement management tools and architecture model tools to help you in maintaining those kind of vocabularies across some kind of name domain. At least the ideas that we discussed here today, I don't think would help you in any way with that consistency, unfortunately. Okay, what about impact analysis and traceability? How do you rate the impact? No, you will not get the same level of fidelity in your impact analysis. So you have to be prepared to pay that price. Otherwise, this is not a good approach. The question I think we should ask ourselves, do we need it? Just because you can doesn't mean that it's right. You can bring on unnecessary complexity by creating more artifacts than you actually need. Introduction of requirements management tools capable of managing large quantities of requirements. Yeah, that's the need to consolidate requirements. A couple of years ago, we just need the tools to manage more artifacts. That's the solution. And of course, we want the tools to be able to manage a large set of requirements. But at the same time, it doesn't really come for free either. It's going to cost to manage a lot of information, and you want to try to reduce it to not be at least more than what you need. And we have run into those things as well. We have outrun kind of capacity guidelines on repositories, and we had to rethink stuff. And we appreciate that the tool vendors do improve scale, but I think we also want to make sure that we don't generate too many artifacts because it becomes so complex to manage. Approach towards verification did show up in the article. All items were met by the same test case. Yeah, it appears it's a good criteria to identify those. Correct. The cinnamon roll example, okay, we're baking them. That's kind of the treatment that we're taking them through. It's the same test case. It's the same test script. That describes that, and we're evaluating a couple of things. If it would have been baking different things, would probably generate different test cases, then that's probably not a good idea to try to merge even more stuff into that, because now you start to get into additional test cases. We have seen that if that happens, if you're trying to bring in too much stuff so you get additional test cases, that's a little bit of a red flag. That probably your under what conditions are changing as well when you do different tests. So that's another good criteria that we're using. The under what condition must be stable, or it must apply to all those things you're looking at. Do you find the development time for the set of requirements to be equivalent for the two approaches? Yeah, that's a good question. I'm not so sure if you save a ton of time when you develop them, maybe a little bit. I don't think that is a significant saving. You still need to think through these things. It takes more time to create 5 artifacts than 1, for sure. So I would say that you do save. We haven't really tried to quantify how much. So, but you would definitely save something when you don't need to generate that many artifacts and later manage them. Comprehension is coming from the natural language. Yeah, I tended more formal means to rational formulation like an objective function. Yeah, I think the previous month there was someone talking about structure requirements and integrating those kind of different parts of the requirements onto attributes on model elements, for example, and maybe that would help in the interpretation. So maybe then it changes the game a little bit, potentially. The assumption here is that it's just kind of reading natural language. It is a human interpreting, not a machine. That was kind of the assumption here. In a model-based approach, go more and more model-based. Maybe it's not necessarily humans interpreting the information all the time.
Yeah, what I was trying to get with that one was that in the requirements guide, which is very good, the need is to communicate upwards towards a stakeholder. And that's really the main point of the natural language requirements.
Right.
That and to write contracts on them. But that communication with the sort of engineering elements, sort of the diving in on it, Well, I understand where you're coming with this one. I'm writing one right now that points you at a resource, which is the Software Engineering Institute's, basically their ILITY papers and Dr. Kasman's work with them on software architecture and practice. They propose to use a scenario-based representation of requirements, non-functional ones being specifically, where this would work really, really well in. Like what I see this working, what you've done is you can basically say, this requirement will be satisfied if this scenario is met satisfactorily, like and define that in the scenario description. When you're talking like in defense contracting for large scale complex engineered system, you've got 20,000 requirements, 600 use cases. It's unmanageable, just as a way to check, because that's really what you're talking about as a trade-off here, is a sort of allocation of resources. So anyways, I'll get off the line, but it was a great discussion.
Thank you. And thanks for the question. I found the March Exchange Cafe very interesting, especially when you're getting to models. So if you did not participate on that one, I can recommend the recording. All right. So Tammy, how are requirements communicated to external organizations when you use the target attribute? Is this a tool exchange or export? You can see that as a little bit as model based. So in order to export this in a more readable format, you run a query. So basically concatenate with the help of that target attribute, or you just export it more of a spreadsheet format. Basically, the format that I showed you in one of the slides is what we use when we print off this. So you're basically generating the document based on the object plus the attributes or the different attributes.
Thank you, Henrik. And I'm afraid we are out of time. I see all the questions in the chat, but we are exactly on the hour. And unfortunately, we're going to have to find a way to send you these questions because I would love to see a follow-up. We can either write something to the team or find another follow-up presentation. This was amazing. It's great information. I think it was really thought-provoking. I know a lot of folks really wrote in the chat how much they appreciated the presentation and the topic. I think this is worth a paper on its own right, and certainly in addition to the guide to needs and requirements. So I would be very keen on seeing if we can get some of this guidance into our next update. Any parting thoughts before we disband the meeting today?
No, but I would be happy to answer any remaining questions offline. So if you can find a way to get them to me, then I would be happy to answer them offline. And I thought about a paper actually, so it might come.
Excellent. You can see the next presentation that's queuing up when you go to our External Requirements Working Group website. You can see we have a topic already starting to formulate for May, and we will put links to various presentations on our intranets site and our Yammer site. That's where you can actually get the file that was presented today. Lou, I think we can stop the recording.